Alright guys, welcome to this super MLG KiCad tutorial. I'm out here. I'm about to teach y'all how to do this shit. Let's get into it. Bah, you don't need this. Alright, you can read this shit on your own time. But basically, PCB is a circuit board. You got 2 to 30 layers of copper with insulator between them. Large copper sheet. SMD, surface mount device, basically something that goes on one side. Doesn't have pins. It has these flat, as seen in the image there. THT is through hole, goes through holes, has legs. Component is just a representation of a part, so a resistor's component, capacitor's component, etc. Symbol is something that represents a component on a schematic, so like this resistor symbol here. Footprint, something that represents a component on a board, so this is a footprint for a resistor like this. A trace track is an analog to a wire. It's just a piece of copper that is a uniform width that goes a certain length and connects different parts. Net is an analog to a node. It's just a connection that has theoretically the same voltage throughout, and it is a place where voltage is constant, which is what I just said. Design process, you don't really need to know it. Just schematic, export this to this PCB editor, create the PCB, and then generate the files to manufacture it. Alright, now we're going to get started. We're going to be building this simple looking board. It's nothing super fancy, but it's enough to keep you going and be kind of fun and kind of a cool project. Alright, so first things first is we're going to create a new project. I already created a new project, as you could probably tell. I'm in the schematic editor. I will leave the schematic editor. You'll see here we have a couple options. I named this one KiCad tutorial, Control N or Command N, and then new one. Alright, we have our project. We have our project going. We're all good to go. Here we go. We're going to start the schematic editing. Okay, so first things first, here's kind of the highlights. I'm going to show you in the actual schematic editor. I find that would be probably the most helpful. Here we are in the schematic editor. I'll be covering, just the basics here, nothing fancy. It may look slightly different on your end, but that's not a huge deal. And if you need to cross-reference, it's always in the bottom corner here. So big things are going to be the toolbar on the side here. This is where you choose all your active tools. And then there's a couple tools on top that are memorable, and then some settings on the side here that are pretty useful as well. First things first is grid. Turns off and on the grid. I mean, helpful, but not like crazy helpful. Units. These determine what units you're going to be in: inches, mils, which is thousandths of an inch, or millimeters. In the US, we're going to be using mils, so select mils on most of your designs, unless you want to use millimeters. In that case, then choose millimeters. But inches are almost never used unless you're using like something huge. All right. Full screen crosshair doesn't matter much. I like full screen, so I'll choose that. This shows invisible pins, doesn't really matter. This is a KiCad 7 exclusive. If it's 6, you won't really have an option here. This determines how you can route things, but by default it'll be 90 degrees. If this is here, you want to leave it on. This is a KiCad 7 thing as well. KiCad 6, this won't be here. Same with your properties or schematic hierarchy. Okay, so big thing here are go to the PCB editor right here, annotate, which basically gives every single part a unique number. Part editor, which edits the footprint, and the symbol editor, which edits the symbols. On the right hand side, we have select. We have net select, which you click on a net and it lights up the whole thing and everything connected to it. We have add symbol, which adds symbols. They're pretty logical. Add power symbol, which adds power symbols, things like earth, VDD, any specific voltage level, it'll add it, no problem. Add a wire, adds a wire, pretty simple. With W is the shortcut. B for bus, we won't be covering buses. Same with wire entry for bus, we won't be covering that. No connection, we'll be covering that. Basically indicates that you don't want to connect that pin to anything. Junction adds a connection point between 2 lines that are going in different directions. Label adds just a label to it. I'll be going over that later. Net class directive, we don't need to cover that. Global tag, you won't be using these, and I suggest you don't use them in general. We'll be using generally just a local label, and then hierarchical label we will also be using at some point, but that'll be for a more advanced tutorial. And then this is for subsheets, which are a really helpful item for more advanced designs, but in this case we'll not be using it. Add text box, add rectangle, add circle, add arc. You don't really need these that much. And then add like whatever polygon you want, and then add an image, and then delete. Those are the big ones. Let's start with the actual process. Here are the shortcuts. I'm going to be saying them as they use them, but you can always check back for this reference for later on. Not a huge deal, but yeah, seriously, do take a look at it. We're going to be making the schematic here. It's a pretty simple schematic. It should look somewhat familiar to you from your Blinky project, the one where you had to blink the LED using the 555. This is basically the exact same circuit, except we changed, I believe, 1 or 2 different values. But it's enough to be different enough where it'll change things and be different blinking rate, of course. Alright, so step 1 is adding power symbols to do this. I'm going to be going kind of fast here because it's a video. You can always go back and look back how I do everything. So we're going to start here, and then there's going to be a dialog option once I click P. So I'm going to press P here. Alright, here we go. So now we have this window popping up here, and it's going to have just a bunch of options. We're going to be going under the power tab. So open up power tab. We need a VCC and an earth. So we can either type this in and search for it, or we can manually search for it. I like to type for it because obviously it saves some time. So double click it, it'll appear. You click again because it'll save your tool option. Click earth. The reason why we do earth and not ground is because the symbol for earth that they have is the European symbol. The earth symbol is the symbol for the US. I know, confusing, but it is what it is, right? So drag and drop there. Now we have VCC and earth. Awesome, cool. We have that done. Super easy. Now we need to add all the symbols for this. So we have a list of the symbols we need, and we will be multiplying them. So for example, we only need 1 resistor, and then we'll be multiplying it later on to have the rest. We only just need 1 unique one, and then add them up. Alright, cool. So we will basically just match this, and I'm going to show you how to do this exactly. We're going to press A. You will see this dialog menu, which is very similar to the one before, but it has a lot more options. So we're going to select a resistor. So R_US is the resistor we're looking for. Again, the US has to be special like that, and the standard symbol for resistor is the European symbol, but the US uses a different symbol. So we have to use the US symbol, which is R_US, which is right here. Double click, drag it, drop it, click again, delete that, type in C. C is a generic symbol for capacitor. Double click that, drag one of those, click it again, and we'll do for the LED. It's the same process over and over again, LED, and you'll see there's a generic LED, and we're going to type in NA555P, which is what I have in the list there. I'm going to type in connector, 2 ends, and you can see there are a lot. I'm going to kind of close out that one and just see the whole libraries, because these are individual libraries. I want just a generic connector for this because we want it to be very standardized, so we'll choose a generic one. So we're going to go to the generic connector library, and we want a 2-pin one. So 1 by 2, 1 row, 2 columns. We see there, it looks perfect. That looks good to me. Double click that. Flip it with R, so flip R twice, or you can press Y to flip it vertically or horizontally there. X and Y to flip it in X and Y direction. Now we have all the components that we need here. We have a connector, VCC, earth, capacitor, resistor, LED. Awesome. So next step is going to be adding the values for these. So for example, the resistors, we're going to have only 1 value, and then we're going to multiply and change the value later. For the capacitor, connector, LED, there's only 1 of those, so we're going to set the value forever for those. So let's do that right now. I'm going to show you how to do that. And it'll be a pretty simple process. I'm going to double click, or I'm going to hover over and press E, and you'll see a dialog menu pop up. Cool. So we have this little dialog menu pop up. A couple fields here. We got reference, R1, value, R_US, footprint, blank. What you want to do is edit the value field. This is the one you want to give it a value. So in this case, I'm going to make it 1K. You can check the rules for naming on the slides there. I'm going to name this one, give this one a value of 1K, 1 kilo ohm. Cool. And then I'm going to rinse and repeat with the capacitor there, 100 NF. Cool. I'm going to call this one red. I don't really know if it's actually going to be red, but I just want to give it a value. Connector, I'm gonna call this battery connector, because it's gonna be connected to a battery or some power source. Doesn't matter. I'm just gonna call it battery because we're gonna assume it's a battery. You don't actually need to do this step, but it's usually for clarity. Cool. This guy already has everything inside here, so we don't need to worry too much about it. We have all these labeled and values are given. Excellent. Next thing we need to do is actually give it a footprint. So this part's going to be kind of complicated, so I'm going to kind of slow down here. I'm going to show you the dialog menus and what you need to look for and all that kind of jazz. So I'm going to first show you the dialog menu. So I'm going to double click into the resistor here. We're going to go back to the Properties tab. Under Footprint, there will be a field here. And inside this field, there's going to be a little, looks like a couple books on like a bookshelf. You're going to click that. This is the Footprint Selection menu. This is a very, very important menu, and it is crucial for this step. I'll make this bigger so you can see it well. What we want to do is we want to look for a THT resistor. So we want to look, this is the Libraries tab. This is the Component tab inside of the library. So each of these libraries has a bunch of different footprints. So library and then footprint within library, and then here's the preview. So I want to look for just resistors. Oh, cool. So I'm going to type in resistor there. It'll pull up all the resistor libraries, assuming that you spell it right and things like that. So we have SMD resistors, surface mount resistors, and we have THT resistors, so through-hole resistors. In this case, we want to use through-hole. That's just an arbitrary distinction made by me because we have through-hole resistors in the lab. So we'll be using through-hole resistors here. So we can check the dock and we can see, we can look through here, and I'm going to go through these in a second. But we're going to see that we need these footprints for these components. So for the resistors, we're going to need R_axial Dano 207 and then whatever else is past that. So what I'm going to do is I'm going to find some part that I think is unique. I'm going to pick this O207. Oh. I'm going to say, okay, O207 looks like it'll be unique between resistors. So I'm going to do O207 here. And I was correct. So we can see Dano 207, there are only 5 options. And we can see that they all are correct. Well, you may not know that, but they all are the same resistor. So what we're going to do is pick any of these O207 resistors. I'm going to pick this one just for funsies, but feel free to pick whatever one you want. Click OK. Cool, you're good there. Now we want to do the same with the capacitor. We can see here we have more options. A capacitor, I'm going to let capacitor again like this, looking for through hole, and we can check the spec. We're going to choose a radial_D blank P 2.0. So I'm going to say, okay, well, I'm assuming this 2.0 is probably a unique value, so I'm going to do 2.0 here. I don't know. Okay, well, it gives you a reasonably good. So we can see P 2.0, P 2.0, P 2.0. These are all close. These are 22 and this 52. So we have, these are correct right here. So we'll pick any of these. I'm going to pick this 4. Why not? You can pick any of them you want. Repeat the process for the LED, LED THT library, and the field would be selected. I hear anything with 3.0 millimeter. I believe there is only 1 or 2. Yeah, there's only 1 or 2. Oh, well, technically there's quite a few, but they're all the same. So anything that has D3.0 mm and it's only 2 pins, you're good. So clear, flat top, or horizontal, they're all the same. So I'm just going to choose the first one I see. You probably can't see that, but I've been doing it in the background there. And then for the battery connector, this one's going to be complicated, so I'm actually going to show this one. So we have this selector here. We're going to look for connector. Now we see there are a lot of connectors here. Too many. So I'm going to make this wider, significantly wider, just so that we can see the names of everything and we can get a better view. So we want a pin header 2.54. Why do we want a pin header 2.54? Well, a pin header is kind of a generic, easily to connect to port. All of the ports on your Arduino Nano, those are technically pin headers. Those are all just individual pins with a very, very standard sizing and spacing. So this is the same idea. It's just a really easy way to connect things that are super generic. So you want to use a pin header 2.54 and find a 1x2. So 1x02. Pick any of these that you want. I'm going to pick this one because it's nice and convenient. Press OK. So now we have resistor, capacitor, LED, VCC, ground, and 555 all have footprints, which is what we want. From there, we can start actually moving things around and start connecting things, which is awesome, I think. Cool. So let's actually get to that. Okay, cool. So let's actually start adding connections here. This is an important step. First things first, you want to move things around so that they are kind of in a place where you want to connect them. But first, even before you do that, you want to actually create the number of things that you want. So we want to add those extra resistors. So Control-C, Control-V, or Command-C, Command-V, and Mac. Control-C, Control-V, Control-C, Control-V there. I want to move this LED around, so press R to rotate it. I'm going to kind of line them up with the capacitor there. Just like that. Cool, cool, cool. That looks good. Move this around. Just click it. Or you can hover over and press M. Oh. Click and press M. Like that. Move this around. You want to move this. Connects there, and you know it's going to connect there as well. So I'm going to make it so it's kind of logical for the connection guide. And we'll kind of match up with what they're doing there a little bit. Maybe slightly vary, just depending on how it works out. So first things first, we'll connect the VCC. So connect the power. Go to the sidebar here, click on the wire, or you press W, and then start where you want to start. So the top part of the connector. We'll start up here to make it easy. Go out here. Connect there. Connect there. Connect there. Cool, the VCC is connected. Well, not quite yet. I'm going to connect the reset to it as well because it's mapped up. Now I'll connect ground. Cool, we'll do that. Ground, 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 ground. Oh, see, this is where you want a junction. If you don't put a junction, these two will not be connected. So, or you can just draw a line to it and then draw a line down. But put a junction there, it'll connect those two. Otherwise, you'll have issues later on. Yeah, that's definitely not one to forget. Now I'm going to kind of put this one in the center of these guys just for convenience sake. Same with this guy. Now I'm going to start connecting this guy to this guy. This guy. This guy to this guy. And now we have basically all of the ones that can be connected. We'll go here to there. We'll go here to there, right? So we got... I'm just looking at the schematic and I'm cross-referencing it. I'm looking at what needs to be connected where. So the 1K. Oh wait. Oh well, I almost forgot. We have to change this one to 100K. So I'm going into the dialog menu, and I am changing the 1K to 100K to match the schematic that is referenced. So we can see it changed to 100K, which is what we want. Now it is a correct value, which is cool. So now we have basically everything connected, but there is some issues. We can't really keep going any wires without doing weird stuff, crossing over, things like that, or it'll start looking a little wonk. Like we do something like that. It just doesn't look very clean, and it's just not a very good way to do things, at least in my book. So the way we get around this is by using labels. So this is the page on labels. Basically shows you how to do it on a more technical level, but here we are. I'm going to show you guys how to use it in reality. So if you want to use a label, you're going to press L. Cool. So we have this label dialog that's going to pop up here. And what we want to do is very simply just type in what we want it to call it. So if you have two items that we want to connect, we want to say, hey, we want to connect your good old boy of, connect this TR pin 2 to pin 6. But we don't want to route something that goes from there up to here. It'll be messy, or there up to there, around there. No matter what you do, there's lots of crossing over, and it just won't look very good. So we want to actually create a label. And what a label does is it allows you to connect 2 points without having a wire. Labels are super helpful, and I think they will be very useful to you later on, especially once you get into more complex designs. Your dialog menu may not look the same as mine, but it's not super important. What you want to do is you want to connect 2 and 6 by creating a common name. So I'm going to call it Thresh, because that's technically what the pin name is. So I'm going to press enter or press OK. I'm going to drag it down to pin 6 there, and then I'm going to press Control C, Control V on it, drag it over to pin 2 over here. Once it's over here, I'm going to press W to draw a wire, or I can, once I hover and press click, it'll select wire for me. Make it look really clean, nice and fresh there. Now I'm going to create another wire label for the Q pin, which is the output pin. I'm going to create one, press L. My dialog will come up. I'm going to write in out because it's the output. Press OK. And what I'm going to do is I'm going to click here and then draw another wire. Now we see that this is kind of clunky. This is kind of weird. The label's kind of hanging off the edge here, and it's kind of hard to tell where it's connected to. The way you fix that is you click it, you press X, and then you can move it over. And then what you can do is you can click on this to add a wire to make it longer, and then it looks much cleaner and it hangs on the edge like that. So refresh X, we'll rotate it around and move it to the end and make it nice and flush at the end there, which will make things way, way cleaner. Much easier to read, at least in my book. Next thing we need to do is put a label here. So we'll just Control C, Control V this guy, just so that we know that we won't make a mistake with naming. Wire there. Oh, didn't mean to do that. We can just draw this, we can drag that over. And then yeah, look at that. We have out there. So these points are connected internally, not with the wire, but internally. Now, last thing is I really want to label every net. So I'm going to label this guy dis here. And I like to have them relatively synced up like that just to make things easy to read. I mean, as long as it's not crazy off, it doesn't really matter. You don't need to follow that convention, but I like it just for my personal stuff. Now we have everything connected. So we have Thresh 2 to 6, 3 to the LED circuit here, discharge to discharge pin, and that's everything pretty much. As for these, you may ask, why didn't I label them? Well, these are already labels. VCC and Earth already labeled these. It's complicated how that actually works, but you don't need to worry about labeling anything that's connected to VCC or Earth. They are already labeled. So next step is finishing up the sign. Last thing is just to add no connects. No connects are basically just these helpers that indicate that I don't want to connect anything. So you go to the sidebar here, and just under these little squiggly things, you got a no connect flag, or press Q over you want it to be. So that, or press Q, which will place one. I recommend using the tool because if you press Q, you have to be right on the money. So now you have an X there that indicates that we do not want to connect this to anything. Don't connect this to anything. We're sure we don't want to connect it to anything. Make sure that you don't make a mistake and leave a pin unconnected. After that, that's basically it. Maybe move it over, move it down or something to middle or something. It doesn't really matter. Oh yeah, here, make sure to press Control S, Command S to save, and then make sure to double check it against the schematic, and I say, oh, it looks pretty good. This looks almost exactly the same as the example provided, but that's part of the idea, right? So next step, I believe, is to start actually talking about PCB. Now we're going to go over to the PCB editor.
If you believe in Darwin's theory, I'm not saying you have to, but it's an interesting theory. Darwin said we all evolved from monkeys. If his theory is accurate, and really who am I to say? Does the opposite work going the other way? If it does, I wanna devolve back to monkey.
To get there, go to the top bar here and click on this little PCB looking icon. Cool. Cool. Now we have the PCB editor open. Let's look through the slides. Here's a little rundown of what the PCB editor is and how it looks and all the tools and stuff. Some of these tools might not be on your build. This is version 7 again, so version 6 will not have the exact same tools, but 99% of it will be exactly the same. The big ones are going to be the left hand and right hand side again. Some of the tools are the same, so grid on and off, units on and off. You may not have units in the schematic, but there's units here. Again, we're going to be using mils since we're in the US. Inches could be used as well, but very uncommon. Millimeters for everywhere else. Okay, if we want to use polar coordinates, you can use polar coordinates. You can see in the bottom our polar coordinates. This turns grid on and off. I have my grid set like this. You can change how the grid looks in your settings. Mine is set like this. I'm going to leave it off for now. Full crosshairs are settable here, same as the schematic. This is the same thing as before with the kind of crazy looking directional moves, so you can do weird directions. I didn't really cover that, but it allows you to do weird things, but I wouldn't recommend it for a beginner. This is rat's nest. Basically allows you to show where connections need to be. They are automatically generated once you import the schematic. And this defines how the rat nest looks. Not a huge deal. We'll go over those in a second, but interactive layers. So when you're not using a layer, so let's see what look. When I'm not clicked on to the red layer, it becomes dimmed. That's to make it easy to use other layers without like losing focus. This guy doesn't really matter, net highlighting. It only matters once you have something inside. It allows you to basically light up everything that's connected to one point. It's easy. It's good to show like debugging and stuff. Zone visibility, not super important. And this is just how to show certain items. It doesn't matter. And then appearance manager on this is the right hand side, just hides this, and this hides this. So you don't really need to do this. On the top bar, we got printing, we got generating manufacturing files, we got importing from schematic, which I'll be using in a second. Go back to the schematic. We got layer selection. And then we're going to be covering tools here. We have selection tool, toggle rat's nest, and then add a object or add a footprint. Really only shouldn't be using this unless you want to be adding like an image or a graphic or something like that. That'd be the only time when you want to use this tool. Add a track, adds a wire as I did before. So a track, yeah, see. And then we have add tune track. You don't need to worry about that. It's a little more advanced. Add a via right here. Vias are basically holes that go through the board to connect one or more layers. I went over this in the beginning, but it's just a quick refresher. Zone, add a filled zone. Zones are basically this large copper planes that connect one or more pins. It allows you to have a really large, low resistance connection to have a really stable voltage across the whole place. A rule area is a special thing that we will not be using, but it's useful. Lines, graphic arc, graphic rectangle, graphic circle, graphic polygon, image, text or like a text box. Add a dimension, see there. Allows you to draw like dimensions, and then delete. Yeah, it's pretty basic there. And then we have setting origin for certain things, and then we have measurement without leaving a mark, so it's just for quick measurements. And then we'll go over the layers. Here's the shortcuts, basically the same as the schematic, but with a couple of different ones. You can always cross-reference these. I'll be shouting out when I use them, just letting you guys know. Here's the layers, what they are and what they mean. All right, we've got the F/B.C, which is front back copper, which is the top and bottom copper layers. That's where all your traces are going to be. We can see that on here as F and B CU. Okay, then we have the adhesive layers, front and back. We don't need to worry about these. These are for more advanced manufacturing. Front and back paste layers. These are where there's going to be solder. So these are usually where just the pads are pretty much on the front and back. And then front and back silkscreen. So silkscreen is basically where all the text goes by default. All right, hi there. So we'll have this text here that'll be in the silkscreen. There'll be any sort of graphics will be on the silkscreen. Front, back, doesn't matter. So the front of the board or the back of the board is silkscreen. Front and back mask are where there's a hole when there's exposed copper. So if there's like a pad or a connection or even a via sometimes, there'll be a hole in the mask, which will be represented in this layer. User comments, user drawings, which are for like anything you want to put on the side. Doesn't actually go into manufacturing. User eco layers and user regular layers are just miscellaneous layers if you need to use them for something. Doesn't matter anything. Edge cuts are the board outline. So let's say I draw something like that. Like that. This will be the shape of my board using a line on edge cuts. As I see, I selected edge cuts and I drew around. Margin, it's not a super important layer. It's usually just used for annotation within parts. Front and back courtyard, these are actually pretty important layers. Courtyards are basically spaces around objects where you cannot have anything else overlapping. So let's say I got two parts. These are represented by these two shapes. I can't move this part where this overlaps with that part for manufacturing reasons. Like it's going to be very difficult to build this if these overlap like that. So the courtyard represents that spacing. Front and back fab aren't really that important. They just show the value of the component pretty much. And that's basically all the layers. So next thing is to actually start building. So we're going to export to the PCB. So now I'm the PCB editor, and I'm going to export, and I'm going to import from the schematic. How we do that is we go to the top bar here, and we see hidden along here we have this option that says update PCB with changes made to schematic. I'm going to click on that. I'm going to make this visible. We're going to see that it'll pass with all errors, no errors. If you see any errors, that means you did not assign a footprint to one of your things, and it'll say could not find footprint for specific items. So it'll be very easy to figure out what's going on. If you're using 6, there will be a screen before this that'll say something like annotate parts, and you just click annotate. You don't need to worry about that too much. And then once they're annotated once, that'll work. And then from here, you just click update PCB, assuming there's no errors. And we can see all of our parts dragged in here. And then once that's done, click close, and it'll close out. We'll see all our parts are being dragged around. I'm going to throw that in the middle there. And I'm going to zoom in, and we're going to look at the layers in action. So we have our LED here. We have see the courtyard, so the pink layers on the outside. Courtyard, courtyard, courtyard. We have the overlap. We see that it's not going to let us overlap those, which is what a courtyard's for. Then we have labeling. This would be on the silk screen. This is lettering. We have this. There would be a solder mask, front mask, back mask here, as well as a back and front paste, most likely. Okay, so we can see after messing around with that we have some fun. We can drag things around, we can move things around, and we can see how all the cool features. This feature is exclusive to 7, so if you have 6 still, you won't have this, but it's not a huge deal. Your color scheme might not be the same as mine, but it's not that huge of a deal. It's the same program functionally. So we have that step done. Awesome. Next step, to create the board outline. To do this, we need to use the edge cuts layer. Select the layer, we go to the right hand side, and then there's appearance manager here. We're going to select edge.cuts. Just click it. It'll show a little triangle next to it that'll show that it's selected. Don't click the eyeball. Click here or click there. Right or left of the color, but not the eyeball. The eyeball will just make it invisible. You don't want that. So click that. It'll be selected. Now choose any of these graphic tools here. So we got line, arc, square or rectangle, circle, polygon. I'm going to choose circle just for funsies. Make it big. It doesn't matter. It's just for this demo. But yeah, please get creative with the shape. You can make whatever shape you want using a combination of these tools. As long as it is a closed shape, it will work just fine. So I made a rather large circle because I want some wiggle room and I want some space to move around and things spaced throughout, and I recommend you use something similar. I recommend that you have kind of a room to move things around so you're not super limited and you don't have to worry about stuff. Cool, that's done. really quick step. Moving components. We want to basically move things around so that the rat's nests are overlapping as little as possible. So we can see the rat's nests are these green lines here. They will probably be a different color for you, but going back here, we can click this option here and we can choose between straight and round. I like round. It's just a personal preference thing, but I find that rounder a little bit easier to kind of see, but choose whatever is most comfortable for you. So what you want to do is move things around. So I got my LED, I got capacitor, I got whatever. You're basically going to move things around so that there's as little overlap as possible. So I'm going to move this over here. See the out, I want to get like that. I mean, I don't mean like literally, I just mean I just don't want these paths to cross as much as possible. So I'll move this connector over here. I want to connect it to be the edge anyways, because yeah, you usually want to connect on the edge. And then I'm going to move like this, like here or something like that. They go like that. And then we can go like that, so we can go there, and then VCC connects there. This. And this is the output, so this goes right here. I'm going to press R to rotate. R once or twice. We have, let's see, VCC, 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 dis, thresh, and then the output. That looks great. The only thing we don't need to worry about is the earth. So let's see earth here. We don't need to worry about any of these that would be rat's nested. So if it crosses in its earth, we don't need to worry about that. We'll be finishing off with the earth at the end. So we have this basic image or this setup. Move this around so it's kind of centered in the circle, just for kind of look-sees. It doesn't really matter that much, but you know, it's relatively important in the long term. And we can see that our non-connected pad has an X and has nothing going on, which is awesome, which is what we wanted. Here we are. We're set up with everything as much as we want. I encourage you to move things around differently and challenge yourself. You don't need to necessarily have as little crossover as possible, but if you do, the less crossover you have, the easier the routing is. But I encourage you to challenge yourself and do more complicated routing. I want to show you guys how to use multi-layers and things like that as soon as we start actually adding tracks. Alright, first things first, before we can actually lay any tracks down or draw any traces, we need to actually determine what size we want the tracks or traces to be. So, in order to do that, we need to actually set up the board and change what sizes are set up in the actual editor itself. So to do this, you need to go over to this top bar here, track, use net class width, go to edit predefined sizes, and you will see this pop-up menu here, just as I've done here. This out of the way a little bit. What we're going to do is we're going to add, so we're going to go to this plus icon on the bottom of tracks and the plus icon on the bottom of vias. We're going to add 2 tracks. First one will be 30 mils. The next one will be 40 mils. So just add 2, add one via, 30 mil diameter, and 20 mils hole. I'll explain what each of these is for, but we're just going to do this for now. Just do as I say. If you want, you can play around in here, but don't change anything. There's a lot of really useful information and kind of cool stuff for configuring your board. Cool. Press OK. Now we want to actually start laying tracks. We can see that I set up here on the slides, but the next step will be actually laying tracks. Cool. So what I'm going to do is I'm going to select my 40 mil trace. By doing that is I go over to the sidebar here, track, and then 40 mils. Select that. Make sure this little thing here, make sure it's clicked off. Now what we're going to do is we want to select track, lay a track. Route tracks is press X or go to the sidebar and click on that. I'm going to click on the sidebar just for clarity's sake. Now I'm going to draw VCC. So VCC will be using 40 mils and then the rest will be using 30 mils. The reason being is that VCC is a power track, meaning that it draws more current than the rest. The rest draw minimal current, so we don't really care about the width. The wider a track is, the less resistive it is. So if we want to have a track that has very low resistance, we want to make it as wide as possible. So VCC, we want to have less resistance than the rest because the rest, we don't really care so much. So we're going to do VCC with the 40 mil track and we're going to start drawing. So click where you want to start and you'll see everything that needs to be connected lit up. which is really nice and handy. So now we're going to be kind of smart about this. We're going to connect here, and we're going to say, hey, thresh needs to connect here to there. So we want to connect there to there first, and then we want to actually go around or something like that. We want to be kind of conscious about what we're doing. So something like that. The reason why I go around the back, and then if you mess up like that, you can go back in and fix stuff. The reason why I go around like that is because I want to make sure there's plenty of connection between here and Earth. I could go here, but these two would have an issue getting connected, but it won't necessarily be an issue, but it's just better practice. Ideally, you want to make power traces as short as possible and as fat as possible, because then it means they're less resistive. But in this case, we're going to be using such little power that it's not a huge deal. The differentiation is more for learning than anything. So once we've done the VCC track and connect all the VCC, we want to just go to 30 mils, select 30 mil size, and start laying tracks again. So all of the ones that are not connected will start connecting. So out, connect, thresh, connect there. Oh, press Control Z to undo there. Connect and make it look pretty clean at least. Nice and clean there. Oh. Yeah, again, if you've messed up, you can just fix it like that. Discharge there, discharge there. And then if you click it, you click delete. So we can see we're just going to connect as much as we can right there. And then that's basically it, pretty much. So we have everything connected there. And I'm going to make one slight change just for aesthetics to make it match up in that style. Doesn't matter. I just like making it look clean to make it look clean, you know what I mean? So we have all this connected, and I think it looks pretty good to me. The only thing we don't have connecting is Earth, and we don't need to worry about that. Oh, actually we have this last thing. The rest we have is Earth. Earth, we're going to connect it at the very end, so don't connect Earth yet. So anything Earth, don't draw any traces using Earth. Pay attention. It says on the pad, thresh. Says in the pad, out, says in the pad your net name. Do not connect anything with Earth yet. Now I'm going to draw something with a via just to show you how vias work, and so you can apply them later on. So let's say I'm going to draw something with VCC, and let's say I can't go, there's no way I can route that without running into other tracks. We'd use a via. So vias work like this. You draw your track, press V, and you'll see that little donut. Press that donut, and you can see your track is blue, and I can cross over other tracks and no issue. See, I can draw whatever you want over here, no big deal. Yeah, so this basically from there you can draw this wherever you want, and then you can press V to go back to the top layer again and then continue drawing. It's pretty cool, pretty useful, definitely a nice tool to have. I'll be using a couple of those later to demonstrate something. And then that's basically the entire circuit. So from there, I'm going to teach you guys how to use as finished routing here. It doesn't look the same as this, but it looks pretty close, or relatively close. Last thing is left is Earth, and it says do not connect to Earth yet. I'm going to add a fill. So how do fills work? Why do we add fills? Okay, so how do we actually build a zone? We want to select the zone tool from the toolbar here, right underneath the via option here. We have right here, add a filled zone. Awesome. So we're going to select that, and we're going to select an area outside of the border, way outside. Click it, and you'll see this dialog menu pop up. And we're going to select both layers. In the layer selection option, we're going to select front and back. Awesome. From there, we're going to select the net. The net basically just determines what it'll be connected to. So I'm going to choose Earth because we wanted to connect all the Earths without worrying about routing. So click Earth, press OK, and draw 3 sides that cover the whole thing. Right click, click Close Outline. Then you have a closed shape. It doesn't need to be pretty, doesn't matter. It'll fix itself. It'll only work within the border. So once you have that, you're going to press B. What B is going to do is it's going to fill in the zone, refill zone. And if you look, once you press B, there is no rat's nest for Earth anymore. You can see there's nothing needs to be connected anymore. We have a beautiful looking board. Looks pretty clean. Overall, a very nice looking board, and I'll be proud to assemble this and show this off. That's basically the end of the actual board assembly. The rest is going to be, that's what I just did this. The rest is going to be cosmetic stuff, so silkscreen. This is a good example to show how silkscreen works. I click on the silkscreen layer, so I go to the menu, I go to front silkscreen or back silkscreen. In this case, we'll be using front, so front silkscreen. We'll see that all the lettering kind of popped and moved itself to the front in a way. We want to move all the lettering, so this R3 for example, we want to move it so that it's out of the way, not in front of everything, not behind anything. So R2, I'm going to move it so that it's kind of, on its own. So it's not covered by anything or not underneath anything. So make sure it's not under here or under there, under there. You want it to be readable so that when you get the board, you know what components are which. So that looks good. I moved this thing around. I clicked it, moved it, clicked it, moved it. Pretty easy. And from there, that's pretty much it. We have exporting manufacturing files, but we'll do that for you guys. You don't need to worry about that. If you really want to know how it works, you can just look at here. And that's basically it. So I'm going to go through and I'm going to show you guys how this works with the 3D viewer. So to access 3D viewer, click Alt 3 or Option 3 if you're using Mac. And then you will see, that I have this beautiful looking board. Now I can move it around in 3D space and I can do all sorts of crazy stuff. I can turn on ray tracing and make it look super hyper realistic. I can do whatever I want. That's a ray traced 3D image of the board. I believe they're on the way of making a GPU accelerated, but yeah, that's what the board looks like, or what it will look like if you actually build it. Looks pretty good. Ray tracing will be really slow and the lighting will be kind of off, but you can adjust the settings. But yeah, that's that. And you can see the vias if you can kind of look. You can see the pads that go through. You look on the side. But yeah, it's a cool way to visualize your circuit before you build something. And you can actually get a 3D model of this from KiCad if you want to model this in some sort of CAD program. But yeah, that's basically it for the Baller MLG Pro Gamer KiCad tutorial. Make sure to save your shit. Always save your shit. So Control S, and then Control S there. And always cross-reference and check your schematic. This is just a very small intro into the world of KiCad. Please message me if you have any more questions or need any more clarification. I'd be more than happy to help you guys out. Thanks. Peace out. Yeah.